Hey everyone, welcome back to Python Code Nemesis. Today we'll be starting with another important topic of domain-driven design patterns, which is how to implement ports and adapters. So let's get started. In Python, ports and adapters is an architectural pattern for building loosely coupled and maintainable applications. It is also known as the Hexagonal Architecture or the ports in hexagon. This will be the agenda of today's video. What are ports and adapters in Python? How to implement ports and adapters in Python? A simple example of implementation and a do-it-yourself task to create a task management application. So let's get started. The core idea of this pattern is to separate the application's core logic from the infrastructure details and external dependencies. The application core consists of the business logic, which can be tested independently of the infrastructure, while the adapters provide the interface to connect the core with the external world. In this pattern, a port represents an abstract interface that the application provides to interact with external components. An adapter implements this interface and handles the communication with the external component. In this way, the application core is decoupled from the specific implementation details of each external component. For example, if you're building a web application, you might define a port for a user authentication service. The application core would provide an interface for the authentication service, but the actual implementation of the service could be done using any number of technologies, such as a DB, third-party API, or custom implementation. The adapter would handle the communication with the specific implementation of the service. Overall, the ports and adapters pattern is a useful approach for building flexible and modular applications, especially when dealing with complex or changing external dependencies. So let's take this small example, right? So let's say for login, you were using a third-party API. Let's say there's Okta, there's a bunch of login libraries that come up, right? So once you were using them and suddenly you decide to not use that and move to a different service. So when you do that, if there is not a port and adapter pattern, it could be so tightly coupled that you have to make so many changes to your application code. But if it is decoupled, all you need to do is make changes to your adapter, and with a very few changes, your application code will be able to move from one login third-party API to a different one. So that's what we are trying to achieve here, decoupling of dependencies. So implementing ports and adapters in Python. Here's an example of how to implement the ports and adapters pattern in Python. Let's say we are building a simple command line application that generates a random number between 1 and 10 and prints it to the console. We want to separate the core logic of generating the random number from the infrastructure details of printing to the console. There is one way to implement this using the ports and adapters pattern. This is a code.py file. Import random class random number generator def generate return random integer in between 1 to 10. So this function of this class random number generator will return a random integer from between 1 to 10. In this code, we have defined this random number generator class. Next, let's define a port interface that the application will use to print the generated number. There's a class print adapter port and a function inside it called print number, which takes in a number, which is an integer. So this is the interface for the print adapter port. Finally, we can implement an adapter that connects to the core logic with the console output. So from ports, import print adapter port, class console print adapter takes in print adapter port, and this print number function should definitely be implemented here. Otherwise, it will raise a not implemented error because this is an interface and it's inheriting from this print adapter port interface. So the console print adapter will have this function print number, which also takes in a number, which is an integer, and prints this, the generated number is, and the number. So this code defines a console print adapter class that implements the print adapter port interface by printing the input number to the console. Now we can use these three components to create our command line application. So from core, import random number generator. From adapters, import console print adapter. Generator, random number generator. An adapter is console print adapter. So you have your generator, which is your random number generator. You have, this is the port. And adapter is your console print adapter. So you generate the number, generator.generate, and adapter.print number. In this code, we created an instance of the random number generator class to generate a random number, and then instance of the console print adapter to print the number to the console. Then we generate all the generate method on the generator and pass the result to the print number method on the adapter, which prints the number to the console. So here's the DIY task management application for you. Let's consider a task management application with the following components. Core domain logic handles the business rules and operations related to tasks. Input ports responsible for receiving input from external sources, such as a command line interface or a web API. Output ports handles the persistence and retrieval of data, such as a database or an external task management API. To keep it simple, we'll focus on the input and output ports in this example. So first, let's create a file called inputports.py, which defines the input ports. So class task input port, def create task, which takes in a task argument. So this is an interface. So there are two functions, create task and get task for this task input port, which takes in, for the create task, it takes in the task argument, and for get task, it takes in the task ID. Next, let's create an output ports module, which is an interface that defines the output ports. So it has two functions, display task and save task, which both take in this task argument. Now let's create the adapter implementations for the input and output ports. For this example, we'll create a console adapter for input and a file adapter for output. Add the following code to the inputports.py file. Class console task input adapter, task input port, create task. So this console task input adapter inherits from this task input port and creates this function, like has to implement these two functions, which is create task and get task. So this is what it does. It takes in an input from the command line console and get task returns the task ID. Add the following code in the output ports.py file. So output port, which is file task output adapter, will inherit from the task output port, will display task, and also there's a save task, which will save that task in a file called tasks.tst. Finally, let's create the application layer, which connects the input and output adapters. So there's an input adapter, which is like initialized to the input adapter whenever we create this task application. And there's a create task function, which takes in the task description and creates a task, which is an empty, and then output adapter to display task. So it displays the task using the output adapter and saves the task using the output adapter. Then the get task gets the task with serve.input adapter.get task and uses this output adapter to display that task. So So now you can run the application using the following code. So have a main function, have the input adapter, initialize it to console task input adapter, and then file task output adapter, and then create a new app, task application, passing in the input and output adapters, create a task, and then get that task. So in this example, we have a task application class that connects the input and output adapters. The create task method demonstrates how a task is created and displays using the output adapter. The get task method shows how a task can be retrieved using the input adapter and displayed using the output adapter. So that's what we saw in the code previously. Next, the console task input adapter captures task input from the console, and the file task output adapter displays tasks on the console and saves them to a file. So make sure to create a file called tasks.txt in the same directory before running the code to avoid any errors when saving the tasks. So you run the example code that I have provided. Create a new directory on your computer to hold the project files, open a text editor and create a new file, copy the code from the previous response and paste it into the file. Save the file with the .py extension and open a terminal and then navigate to the directory where you saved the file. Run the Python script by executing python3 main.py. So I recently ran this with GitHub Codespaces, which was really cool and that was really fun doing that. So yeah, I definitely recommend doing that if someone is having any issues locally. That's like really helpful. And when you run the script, it will create a task by accepting input from the console and displaying it on the console. Additionally, it will save the task to the file named tasks.txt in the same directory. So that's it for this article. All the code is available on this GitHub code repository. By using the ports and adapters pattern, we have separated the core logic of generating a random number from the infrastructure details to printing it to the console, making the application more modular and flexible. So let's say if there was some more business logic or logic involved with this task, then all of that would be inside the application's core structure and none inside the input and output adapters. So that is where this ports and adapters pattern helps us. So that's it for this video. Feel free to leave comments, feedback, suggestions, and please like and subscribe if you watched till here. And for more Python videos, for more interesting Python frameworks, please follow. And thanks for watching. Happy coding.